we all have a vision in the future of research being part of care, right? And making sure that all of our patients or patients in our healthcare systems are getting the best care that they can. And sometimes that isn't the standard of care. Sometimes that's new stuff that's under research, right? So that's a goal, right? I think we can all agree on that, right? So how are we going to get there? And that's by, in many cases, finding trials for our patients or research subjects, right? So that's what I'm going to talk about today, us trying to do this as part of the Precision Health Initiative. So first, a little definition. So what do I mean by trial matching? So there's actually at least 3 categories of trial matching. First, as a researcher, I have a clinical trial, or I'm going to work with a trial sponsor, and I want to find patients for my trial, right? That's that we get a lot of that was we're trying to land trials on site here. Second, as a patient, I want to discover if there are clinical trials I can volunteer for to treat my condition. That's the second kind of trial matching, right? Where I'm trying to find something for me. And third, as a clinician, I'm looking for clinical trials for my patient, typically as part of a tumor board. And so for us, that's what I'm talking about today, right? That's the context that we're talking about as part of the Precision Health Initiative. So specifically, I'm going to be talking about this research context. So we're focusing today on the Precision Health Initiative Adult Precision Genomics Program, the APG program at the IU Health Simon Cancer Center. Also, it's also part of the Indiana Institute for Precision Medicine. Is it personalized medicine? Personalized medicine. Personalized medicine. And this program focuses on patients with metastatic solid tumors or rare tumors with no standard of care options. So they've run out of standard of care options. The patients are then seen by the APG group. They are consented into the trial where tumor and germline sequences are generated. So now we have genetic-based biomarkers for them. And then the tumor board evaluates the subject's clinical and genomic data and recommends a biomarker-informed next line of therapy. So that's the trick, right? And that's why it became difficult for us, because we wanted to have a biomarker-informed clinical trial match. So first of all, what biomarkers do we use? So germline mutations, somatic mutations, but also these typically get receptor statuses such as PR, ER, HER2. Many of you are probably very familiar with these. And these, and if you're negative in all 3 of these, then particularly if you have breast cancer, then it's the classic triple negative breast cancer, right? Which is of concern because it's 10 to 20% of breast cancers. Plus, they tend to be very aggressive, and so we care a lot about trying to get the correct therapy for them. So there are a bunch of clinical challenges to this. So first of all, standard of care therapies largely do not consider biomarker variation. So if you just go to your typical cancer center and you get diagnosed with cancer, or you have a refractory cancer, and you're looking for the next standard of care, there's no way for you to incorporate biomarker evidence into that next line of therapy. FDA-approved therapies have limited options. There's not that many biomarker-based or biomarker-informed therapies out there. The good thing that we want to take advantage of is that trials can make innovative therapies affordable. So if you become part of a trial, this is standard, right? You want to become part of a trial so you don't have to pay for the meds. And then there's a trend towards biomarker-based trials of experimental oncology therapies, which means that a lot of pharmas now are looking for biomarkers as an inclusion-exclusion criteria for their trials. So we need to know about them so we can get our patients on those trials. And also this is being pursued by folks like NCI. The NCI MATCH trial, for example, is biomarker-based rather than a body site-based. In other words, it doesn't matter where it's in your lung or wherever. But where they have 18 arms, they're matching genomic variants and drugs, right, to try to get people on those trials. And so, some of the NCI match trials are of relevance to the patients as part of the APG program, and they're also some of them are landed here at IU as well. So let's look at kind of how big is this problem, right? This problem that we're trying to solve of finding biomarker-based therapies. So beyond FDA-approved therapies, we're not really always aware of them. So if you look at the big blue circle out there, I did a search earlier this week, 18,541 trials in ClinicalTrials.gov that are recruiting in the US as of the 14th of this month, right? So that's pretty big. That's a pretty big number. There are around 5,000 of them are oncology trials. 2,900 of them are biomarker-based oncology trials. So you can see that already more than half of the oncology trials that are out there in the United States that are available for our patients are biomarker informed. In other words, the biomarkers are inclusion-exclusion criteria for those, right? Or they're really trying to align the biomarkers with the therapies. So, but now you look at kind of the little circles, right? Where we are now there are 170 oncology trials at IU. Not all of them are biomarker based. Not all of them have are in ClinicalTrials.gov. In other words, they don't have NCTIDs. And so there's a little bit, and there's that little, like the little blue dotted circle are biomarker-based trials our oncologists are aware of. So, you know, just through professional collaborations, our oncologists are aware of trials that are going on, but they really have just a small visibility into this larger group of biomarker-based trials that we really want to try to make available for the folks as part of this group of people who have these recurrent cancers, right, where they've run out of standard of care therapies. Of course. Yes. Let's make this interactive.
You have a very small slice of the 170 oncology trials at IU outside of the ClinicalTrials.gov. I thought every clinical trial had to be registered.
Not all of our oncology trials actually have NCTIDs. So that was a problem, right? That became one of the challenges for us. So can't we just use a ClinicalTrials.gov site? It has an API. So API, for those of you who don't know, is Application Programming Interface. It's a way for you to work with a system like a software on our site here and put information in, and it would automatically send a request to their server, which would automatically return results. So we'll be talking about API-based systems a lot, because that way you can work with your data on your system with your patient, and then have an automatically kind of return response from some sort of resource like ClinicalTrials.gov to pull back information that's relevant to your particular case. So it does have an API, but doesn't work for us. The trials can be searched by disease and many other factors, but not by biomarkers. And so you can't go in there and look for a KRAS mutation trial because it just isn't listed in ClinicalTrials.gov. And even more perplexing is that biomarker data in trials listings are not described in a fashion that encourages discovery. So what am I talking about here? There is competition among the pharmas, and they really don't want to make it easy for their competitors to understand what kind of biomarkers they have trials for right now. So they don't want to make it easy for us. They don't want to make it easy for their competitors, and we're kind of caught in the crossfire of us, right? Because there's kind of perverse motivations for that. So with that understanding, this is kind of what we had to work with. When the study participants come in, they get sequenced from both Foundation Medicine and or Nantomics. These provide CLIA-based sequencing for us. So they are clinically actionable. We get a 400 gene panel from Foundation Medicine, and Nantomics gives us whole genome sequencing. So that's a huge data set that we get from Nantomics as well. So we have already put a lot of we put these clinical and genomic data on the Lifomics platform. They're our kind of technology service partner on this. And they can ingest and index all of these data as individual data objects. And for a variety of purposes, not just either looking at an individual patient or looking across the patient cohort, many uses we have for that. And one of them obviously is for trial matching here. They have a tumor board application, and you'll get to see a picture of this later. I know you're very excited to see that, where you can look at the timeline for a patient and see what's happened in terms of their history and all the variables that go into that. And it aggregates a broad array of data, all the clinical and genomic data, so that you can see the data for each person. That's kind of the starting point for us to be able to get to a place where we're getting to trial matching. So our trial matching solution had some requirements that came from our clinical research team. They had to abstract and regularly update trial biomarker data, right? Because the data are listed in text in the text part of ClinicalTrials.gov. So somebody has got to go in and pull those out as structured data elements. It has to support the API-based queries because we wanted them to be able to work in our app, the clinicians to work in our applications and be able to get that information back from wherever it had to be. I needed to quickly return an accurate list of clinical trials, and it needed to include IU trials, even if they don't have NCTIDs, right, to Titus's earlier question. So we did a test, we did a bake-off, if you will, or a Pepsi challenge, right? And across a bunch of different vendors, and Genome Oncology was the company that ended up responding the best, and kind of here's why. They do weekly updates. They're working with Mia Levy and Vanderbilt, and they're as part of their My Cancer Genome Project. They are doing weekly updates and abstractions of clinical trials that come into ClinicalTrials.gov. So we knew that we would be getting regular updates of all the trials. So that helped solve that problem of the fact that we didn't, of getting timely information about the trials that we're recruiting, because you know they come on and come off pretty quickly. It does support API-based queries with Lifomics. That was great. Nice checkbox there. They had the highest sensitivity and specificity of all the results. So Milan Radovich, who was the genomist working on this project with us, ran all the companies through the test, and they actually produced the best results in terms of the accurate results, return of trials, and it was like less than 2 seconds. So if you're a clinician, that makes a difference, right? You need to get those results. It matters whether you get those things back in 2 seconds or 30 seconds or 2 minutes, right? And then they were willing to create a data set customized for us that it would query against that added our trials, and they're regularly updated too. And I think we agreed upon a week that every week they will be updating our trials as well. So that was a nice thing that they were willing to do for us. So here's how it's supposed to work. The IU Regenstrief team pull in EMR data, the clinical data, study data they've collected as part of the study, the genomic data from our sequencing partners. We stage all the data, we integrate it together, we create it as FHIR objects, that was a lot of fun. And then we push those FHIR objects over to the Lifomic Precision Health Cloud, basically their Amazon Web Services platform. They have an application that sits on top of that looks down at the data and pulls the data out, their patient viewer, so you can see all the information about their patient. And then when you click on the magic trial match button, it sends the relevant clinical data, as well as the genomic variant data over, as well as the receptor status data over to Genome Oncology. It sends back a list of trials that match that. So it sounds pretty simple, right, once you get everything done, right? So we had a couple challenges, right? It's never easy. So we had a couple challenges. The first two were just getting the data in. Each sequencing company uses their own version of standard file formats. So the way to solve that was just work, and a lot of work, and with our team and working with the Lifomic and the Genome Oncology folks to just get those data in there and sorting through that variability amongst those standards. And not all tests test for the same list of variants. So absence may not indicate not tested. So this is important if you're doing a trial where absence is an exclusion criteria. So if you do a test and you're not testing for that gene, it doesn't mean that the gene's not there. It just means you didn't test for it. So we need to be able to discern that as well, right? So they did this, they characterized each test. In other words, whether it was a Foundation 400 gene panel or whether it was a full genome VCF coming back from an anatomic, they actually knew what genes were or were not tested for each of those panels, so they were able to determine whether it was not present or just not tested. Second set of challenges, some of the genome variant files, the variant calls were too big, so they were representing over 1 million variants in a whole genome sequence. So in just indexing those and sending 1 million variants over to Genome Oncology to respond back we couldn't scale to do that, right? And second, it's unlikely that people will travel over 100 miles for treatment, right? We just wanted to make sure that we were trying to find the trials that our patients could actually participate in, or were willing to participate in. So the way we solve these problems so far is they provide a list of 600 genes that are currently listed in trials. So this is not necessarily the 600 genes that are pathogenic or we know they'd be pathogenic. They are the list of 600 genes that are actually being considered as relevant for biomarker-based trials, right? So it's not, it's not, do they make you sick? It's, are they part of a list of that are being currently searched for trials? And they update that regularly for us as well. And then we return the results, return them back within, how close are you to Indiana University School of Medicine? So we list those trials first that are under 100 miles out. And we list all the trials that come back, but first we list the ones that just come back and that are less than 100 miles away. So here's what it looks like. Oops, hey, that's no fair. You're not supposed to see that one yet. But it always does that to me. So here's how we send out a query. This is the patient viewer, and it shows a patient care timeline. There's some, you have various timelines across diagnosis here. You see when chemo was delivered in the red, and in blue are visits of this particular person. Up on the upper right, you just click the button that says trial matching. We try to make it really easy to start with. And then this is what gets returned. Oh, come on. Returned. There we go. Here's what's returned. In this case, this person had a whole bunch of mutations. You can see them in the little, I guess, gray for you boxes across the top. There was a KRAS G12C mutation that that matches here. So that was the first one that came back. There's someone who's looking at a phase 1 trial that is specifically looking for people with KRAS mutation. The second trial actually is looking for an mTOR mutation, which also is another mutation that they have as well. So we are able to pull back, and this, like I said, these results come back in less than 2 seconds. So it's pretty amazing for a clinician. They actually qualify based on the mutations that come back. So we're very happy with that. It shows the distance, it shows the phase, it shows the status, whether they're recruiting or not. So really, really useful, and they've never had access to this before. So all of a sudden, think back to the slide of all the circles, whereas before, you know, they would kind of root around with their colleagues and figure out what trials might we have available of the 170 plus more that we might know of, to all of a sudden we have instantaneous access to, within a week's delay, of the 2,900 trials, that oncology trials that are biomarker based, which is a pretty important change, I think, for us, right, and for these clinical teams. So that's where we are. That's what we've gotten accomplished so far. Milan showed this off at the Precision Health retreat yesterday, and it worked. So you know how technology demos, when you do live demos, they never work, right? So this one worked, which means that it must be pretty well done. So I really have deep appreciation of the technical team who did this. So what's the next steps? Putting this into production to support the tumor boards. Milan is already using this on a day-to-day basis to look for trials for his patients. The patients in the APG group. We're going to be customizing the submission list to pick from a list of diagnoses and biomarkers. So you'll be able to say, I want this primary diagnosis and I want you to only search for these gene mutations. That'll be like a pick list. We'll do that next. And then we're going to get feedback on the tool from the clinical research teams to continue to kind of iteratively improve it. And then ultimately, right, goal 4, right, to assess the success of trial matching. Will this actually result in improved patient outcomes, right? Will these therapies that we're finding for them, we'll be able to get them on trials, will those trials have better clinical outcomes? So that's kind of where we are with the project right now. So I want to thank the team. We had a team from Regenstrief and IU, a team from Lifomic, and the team from Genome Oncology that all kind of huddled together to get this pushed through and get it up and running. I want to make sure to specifically thank them because for all of their hard work, so I could get up here and talk about their success. So that's it. Thank you. Questions? Here's going to be my email address as of January 14th. So thanks. I don't know where we are. That's it. There wasn't much more. It's a work in progress. Yes.
Great work. I'm just thinking about the flow. So your user are tumor board. Correct. So is the tumor board scalable solution, like that is in every academic or non-academic center have a tumor board in general?
So not all of cancer care is done through tumor boards. As part of the APG group, they do have a tumor board where they get together and they talk about. They have the clinical research nurse there, the pharmacogenomicist there, the genomicist there. pharmacist there, genomicist is there, the oncologist is there. They all sit around, they go through case by case. So if you look at this type of interface here, this is important for them to look at what's going on with our patient right now. And then as we get trial results back, they'll want to look at what's been the patient history, what's been the history of care to date, what drugs have they been on, what drugs might they respond to, and they will go through this list of trials and say, based on this list of trials of options, we will look at all the other factors that we understand about our patient, and we will or will not, want to recommend trials.
So they don't have the restraint of Cerner or Epic monopoly to be the porter.
Now, this is a research
outside.
study. So ultimately, our researchers will then put their clinician hat back on, and then they will recommend therapies back to the patient coming out of the tumor board. So it's kind of a. But all of the genomic data, like I said, they're all CLIA certified, so they are clinically actionable data.
I'm thinking more of you are in the early on of trying to fix a big problem, correct? And a very personalized problem. I'm trying to think, can you think about scalability up front? So, so an example, most likely your plug-in solution going to have to be, except if something changed, plug into Cerner or Epic.
Yeah.
And is whatever you're creating your prototype right now, is it very easy, will be later on plug in, or do you have to go back again and try to create another prototype that will match the plug-in to Epic or Cerner?
Yeah, so we get automated data feeds from Cerner already. So that part has been solved. So once we send a patient into the trial, we can start flowing their data in an automated fashion. I think those are weekly updates as well, because the tumor boards happen on a weekly basis. And that can, I think, scale. One of the big bottlenecks was just the ability to pull all the data together quickly, so the tumor board team didn't have to do that manually. So that actually reduces that bottleneck quite a bit, just in terms of their workflow. And the ability to do the trial matching is just something they just never had before. So that also allows them to not only put their patients on trials, but I think discover trials for biomarkers that they might be interested in as well. So the other part that you might think about is, well, what about beyond oncology, right? So it's possible that if you are abstracting, and right now we're only getting the abstractions of the oncology trials from Vanderbilt, but if you have other biomarker-based trials that are being abstracted in CT.gov, another service pops up to do that, this could expand beyond oncology. And it obviously could rapidly expand to other teams. And once we have the pick lists of mutations, it's possible that you could say, well, I don't even have a patient. I just want to look for trials for anybody with this particular mutation, and you would be able to type in the mutation, and then it would search for all trials for anybody with that mutation. So I think those, and because of the way the platform was built and the modularity of it, we could with a pretty low barrier to expand into that, into others. You're looking to expand into other areas of oncology and even potentially into non-oncology areas. Titus.
So you had on your kind of goal slide, you had listed improved patient outcomes as one of the things.
Yeah.
I would actually put one in front of that, a process outcome, which is enhanced recruitment into clinical trials, because we know that clinical trial recruitment is actually very low compared to the people who could be in it. The last figure I remember is like 5% of eligible people. Do you have any sense of what magnitude this could result in? I know it's really new, so you don't have any real data yet, but maybe you can speculate.
I think it's going to be somewhat minimal in the greater scheme of things. There are 1,800 patients in the APG group right now, so for us that's pretty big. It's one of the bigger programs nationally. So, but I think that actually going through the step of, yes, we've recruited them, yes, we have sequenced them, yes, we have found trials, potentially found trials for them, but how many of those will actually go on a week-to-week basis to actually go on, get on these trials? I think I don't know that I'm that encouraged that will make a huge dent. There are 2,900 trials out there. I don't know that we're going to make a huge dent in that right away, but hopefully it will benefit our patients. All right. Yes.
Can you add add other inclusion/exclusion criteria to improve that matching? So I know you're doing the matching based on the biomarker, but theoretically, maybe you can plug in all these other criteria and create the algorithm to match, and that way they don't have to travel, 100 miles or so, and they come over and they find out, whoops, they meet that criteria, but they don't meet all these other criteria.
Yeah, the big barrier right now has been the biomarkers. So we've tried to 80-20 the problem. Right now we search on primary diagnosis, gender, age, and biomarkers. So those are the things we're able to search on. Those are the things that genome oncology is able to return. So I think we've taken a big bite out of the elephant on this one, but I think you're right. There's lots of other ways to try to improve this system into the future.